We will continue with the types of operating systems. So what are the types of operating systems that are available? Depending upon the kernel type and the kernel services, purpose and the type of computing systems where the OS is deployed and the responsiveness to applications, operating system can be classified into different types. Especially we call it as a general purpose operating system and a real-time operating system. So before getting into that, we will just get an idea about what is a general purpose operating system and a real-time operating system. So in the case of general purpose operating system, for example, your Windows system, what are all the tasks that are running, right? So there will be plenty of tasks. I think when you open your system, you can see there is an antivirus is running, there is a Word document is running, there is a music file that is running in the background. So there will be hundreds of services and the processes will be running. And at any time, which process is being executed by the processor which is available? Say for example, i5 may be your processor, right? Intel i5. So there will be only one processor and more than 100 tasks or processes are running, right? I think we can use the word task, right? So one processor is available, Intel i5, let us assume, and 100 tasks are there. And who will take care of which task should be run in the processor at any given time? Normally the OS will take care, right? So if the OS takes care of all these things, the priority assignment for different tasks and scheduling the task into the processor and all those things, then that system is actually called as a general purpose operating system. Windows is a best example for the general purpose operating system. And in the case of real-time operating system, the user should specify the priority and scheduling for each and every task so that the user can understand at any time which process will get executed in the processor or which task is executed in the processor, right? Say for example, suppose if I am having some 100 tasks, right? I will write the code for 100 tasks and I will give the schedule. The task one is actually given the highest priority. This should be executed between 8, say for example, this time X to time Y. So you can specify the time at which that needs to be executed and what should be the priority, so that you can get an idea about which task is getting executed in the processor at any time. So that is actually called as a real-time operating system. So that is actually the difference between a general purpose and a real-time operating system, right? We will see just one by one. The general purpose operating system which are deployed in general computing systems are referred like that. And the kernel of such GPOS is more generalized, right? And it contains all kinds of services required for executing generic applications. And the general purpose operating systems are often quite non-deterministic. So we cannot determine which process is getting executed in the processor, right? Because it will automatically take care, right? This process allocation and the priority, it will automatically take care. And GPOS are usually deployed in computing systems where deterministic behavior is not an important criterion. And the personal computer or desktop systems are best example, especially Windows XP or whatever it is, right? So these are all general purpose operating systems. On the other hand, the real-time operating system implies a deterministic timing behavior. So the user should be able to identify which task is running in the processor at any time. So the deterministic timing behavior in our task context means the OS services consumes only known and expected amount of time regardless of the number of services, right? That's what I said, right? And a real-time operating system or RTOS implements policies and rules concerning the time critical allocation of system resources. So how to allocate the resources for each and every task? Again, everything need to be properly scheduled. And predictable performance, because we have given almost all the instructions, right? And this is best achieved by the consistent application of policies and rules. So we have to define some policies which tasks should be given here. Only based on those policies the tasks will get executed. And the examples for the real-time operating systems are Windows CE, QNX, VXWorks, Micro C and OS2. So these are all some of the examples for the real-time operating systems. Now we will get into the real-time kernel. So the kernel that is used in the real-time operating system is known as a real-time kernel, and it is highly specialized and it contains only the minimal set of services because it's going to be a real-time operation, so we cannot load it with so many processes, right? So it will be having a minimum set of services that is required for the user application. So what are the basic functions, right? So again, already I said the task and process are both are equal in terms, we can say. So instead of using process, we will use the term task, right? So it is task management, task scheduling, task synchronization, error or exception handling, memory management, interruption handling, and the time management. So these are all the functions of a basic real-time kernel. And the basic real-time kernel task process management means it deals with setting up the memory, right? So here the task management or process management, there will be a task control block, right, which will be providing the details about the particular task, right? So what are the things it will deals with? What is the memory that is needed, and you have to load the task into the memory. Then we have to allocate the system resources for executing. Then you have to execute this task control block, right, which has the details of all the tasks. And once the task is done, we have to terminate or delete the task, right? Now what are the parts of a task control block? We will see here. The task control block will be having these informations. One is the task ID, right? Each and every task will be given a separate ID. Then state. So whether the task is ready to get executed, or it is waiting for some user input, or waiting for some peripherals, or waiting for some resources, or the task is completed, right? So there may be different states. So the task state will be available on all the time. Then the task type. So what type of task it is? It is actually hard real-time or soft real-time. Again, there are two variations are available. Of course, we are going to see what is hard real-time and what is soft real-time, maybe in the later slides. And the task priority. So already we discussed which is the highest priority task and which is the lowest priority task, right, that needs to be done. And the task context pointer. The context is saving at any point of time what is actually the status of the task, right? That is actually the context of the context of the particular and task. And in that case actually we have to store it. Suppose if you are leaving a task for some time and you are getting back to the task, right, because of some interrupt and all those things, then you should know the execution status of the task. For that we need actually the context saving. And then task memory pointers. So these pointers will be having the code memory and the data memory and stack memory for the task, where the data pertaining to the task is available in the code, data and the stack memory. Then the task system resource pointers. So this pointer will give the system resources something like semaphores, mutex, right? So these semaphores and mutex are some sort of protection systems for data, which we are going to deal, of course, in the later slides. And the task pointers to other TCP. So there will be multiple tasks that is running. So there will be multiple task control blocks. So among the different task control blocks, which is the recently completed task, which is actually the task that is waiting, which is my next task that is to be executed. So these information should be available in the task pointer, and some other parameters that also be available there. And the parameters and implementation of the TCB is kernel dependent. So based on the kernel or based on the OS, so it will be having different parameters and implementations will be available. The TCB parameters vary across different kernels based on the task management implementation. And what about the task management services? For TCB, what are the things we need to do? First thing is we have to create a TCB for creating a task. So whenever a task is created, then a corresponding TCB, a task control block will be created, which will be having the details about the task already we discussed. And then suppose if the task is terminated or deleted, if the task is over, then the corresponding TCB should also be deleted and removed. And at any time the TCB can be read in order to get the status of the task, whether the task is getting executed or waiting for the user input, or what is the present status of the task that is available in the TCB. And update the TCB with the updated parameters on need basis, right? Say for example we have one context, say for example you are saving in one position, and after that you are saving to another position after doing some more changes, right? So there will be the status changes, right? That is actually called as context. So at any point of time the present status of my task should be updated and saved in the memory. So that again updation of the TCB is possible. Then modify the task. Suppose initially one task is given the highest priority. After execution of it, then some part of it, now the priority has been reduced. So in that case I should be able to change the priority level of the task dynamically. So that is again done by this TCB management system. And we will see just one by one. First is the task scheduling, right? So task scheduling means there is only one CPU there are more than 100 tasks. So we have to make the tasks available in the CPU. Whenever the corresponding data is available for the task, then that should get executed, so that my CPU should not be idle at any point of time. That is actually our main intention. And task synchronization deals with synchronizing the concurrent process access of the resource, which is shared across multiple tasks and the communication between various tasks, right? And error and exception handling. Suppose if there is any error, right, what type of error may happen? So there is some list of errors are given here. For example, one is actually called as an insufficient memory, right? So I need more memory, but the memory is not sufficient. Then there is a timeout. I am waiting for an input from the user. He hasn't given the input, so the system doesn't know what to do. So there is a timeout. Especially you can see that in your ATMs and all those things. Whenever you fail to give the input at the correct time, then the system will say it's a user timeout. You have to restart from the first. Then there is a concept of deadlock. Of course, we are going to discuss that. Then there is a deadline missing, right? Within that particular time, the task should be completed, but the task is not completed. Now, whether I have to complete my task or not, again, I don't know. So that is actually called as deadline missing. So the deadline is over. The task should have been completed by this time, but the task is not completed. So whether I have to continue and complete the task or I have to drop the task, again, that need to be done. Then bus error, right? So there may be some hardware error maybe in the bus, and divide by 0. Suppose C equal to A by B is coming and B value is 0.